Hey guys, today I'm going to be telling you about converging lenses. So the first thing you need to know about a converging lens is that they are all convex. This just means that the lens gets fatter going towards the middle. So you can see on this lens here, the lens gets thicker and thicker going towards the middle, and this causes all the rays of light passing through the converging lens to meet at the focal point, which is here. And also, all lenses have a principal axis, which is basically a line that passes straight through the middle of the lens. So the principal axis of this lens will be around here. And you can see that the principal axis is in line with the focal point. The focal point of a lens is where rays initially parallel to the principal axis meet. And this is the focal point because all these rays passing through the lens meet at that point. Every lens has two focal points, one in front of the lens here and one somewhere behind the lens. And the focal length here, let's say if this focal length was 5 centimeters, then the focal length of this bit will also be 5 centimeters. And what I mean by that is that if say if rays were coming in from the lens this way, then because the lens is still the same size and is still converging, then all these rays will actually bend and have a focal length the same size here in relation to this focal length, though the focal length of a lens will always be the same because the lens never changes, and this is only true for converging lenses. The focal length of a lens is just the distance between the middle of the lens and its focal point. So here is the focal point, and you can see it. By the way, this focal point here, it can also be referred to as the focus. Focal length is directly related to power. The more powerful the lens, the more strongly it converges parallel rays of light, so the shorter the focal length. So the more powerful this lens, the shorter the focal length, because the more powerfully it converges the lens. This means if this lens was much stronger than what it is right now, say if it was like this thick, then its focal point will be a lot smaller because these rays will be converged much more strongly. So say if we have a lens and we can measure the focal point, and it says this focal point is 5 centimeters. Sorry, I mean focal length. And we want to find out the power of this lens. Well, there's actually a method we can do this. We do 1 divided by 5. And here's the formula. So power equals 1 divided by focal length. And in science we always use meters. That's the more standard way of measuring things. And the D stands for dioptres. Not sure how to say that. Anyway, so you always do 1 divided by 5. And this 1 is there always. So I did 1 divided by 5, and that equals 0.2. And remember, the unit for measuring the power is D, so we write 0.2 D, and that is the answer. And just remember, the smaller this number here, this one right here, the bigger this number. So say if you did 1 divided by 0.2 meters, you would get 5D, which is of course a much larger amount. So the shorter the focal length, the more powerful the lens. And another way to, actually a way to increase the power of the lens, you would have to make the lens more curved, so more strongly curved, and that will increase the power of the lens. But also you can actually use other types of glass to make that lens, to make it more powerful.